exponential is unit 3, so I can give you that after this. Okay, so I'm going to get started. Yeah. So I'm recording this, so if you guys need to look at it again, you can. But for now, you don't really need your computers. I'm just not going to start it. So if you can focus, you can only get extra credit if you're like engaged, you are paying attention. If you guys need extra paper or you just want to write on something and then we can transfer it to here, you can do that. Or if you just want to follow along and once you get the paper, you could transfer it. But everyone in Ohio State should already have this. Or if you were here last time, then you should already have it too. So, cool. So, it says which graph represents these two things. So the first one, I have y is less than or 2/3 x. So first of all, should this be dotted or solid? Dotted, right? And so that line should be dotted, and it should be 2/3. So that means I rise 2. So rising 2 over 3. So looking at the dotted, let's pick 2 points and see. Is it 2 over 3? So from here to here, what do I go up? 1, 2, 3 over how many? 2. Is that 2 over 3? No, so that can't be it. And you can see this one looks like it, so it's the same one. These two are 2 over 3. Now, should I shade above or below? Right here, right below, because y is not being equal. So which one has below the dotted line? C. So automatically you know C is the answer. If you look at the other one, just so we can go over it, so remember, don't waste time if you don't need to. So it's y is greater than or equal to negative x plus 2. So we can see we started at 2, and then we went down 1 over 1. And we shade above, so it's above this line right here. So it should be above his head. And so that any of those points in the shaded region are your solutions. So remember, you can always take a point in here, so that you can always take like 5, 0, plug it in for both the equations and make sure it makes sense. So that's just a way you can check your work. Does that make sense? Cool. All right. Next one is, so they're talking about some cinema that sold 150 tickets to a movie. So that's my total tickets, right? Some of these were child tickets and the rest were adults. A child ticket costs how much? $7.75. So we can probably say that $7.75 will go with what letter?
C.
C. And an adult ticket is $10.25. So what letter would go with $10.25? And they want to put A first. So $10.25A plus $70.75C. And how much money total did they sell? Cool. So remember, money goes with money goes with money. So if it's $10.25 per adult ticket, $7.75 per child ticket, what's the total money? $1,470. Perfect. Then no matter what an adult ticket costs and no matter what a child ticket costs, how many tickets did they sell? All right, cool. So, again, okay, so it's A plus C equals 150. That's your total tickets. So what would be your answer?
1.
Good. So some questions are just going to be putting the equations together. So don't solve it, don't do any of that. You see the answers are just equations, you're just lining up which one goes with which. And you guys saw like there's highlighting tools and things like that on your formula sheet. Just so you know also how the test is there's only 10 questions that are non-calculator questions. So the first 10 that you're going to take, your part A of section 1 is non-calculator and the rest of your whole test is calculator. Only 10 questions down. Wait, so section 1, part A is 10 questions. Then you would go on to part B. We'll talk about that after session. We'll be going over that. All right, this one. What should I do with my answer choices? Plug them in, right? And so all I did your answer ended up being this one, and so I plugged in -3 for your x coordinate and 2 for your y coordinate and solved. So when I wrote this, instead of y each time, I put my y coordinate, and I want to make sure it makes sense. So like this, and you have to do this for inequalities or else it doesn't really work. So I'm going to put in my x coordinate, which is -3, and my y coordinate, which is 2. So let's make sure it makes sense. What's -12 times -3? Positive 36 plus 4? 40. Is 40 greater than or equal, or greater than, what's 2 times 2? 4. Is 40 greater than 4? Yep. Let's try this one more time. 2, is it less than, what's negative times a negative? Positive 18 plus 4. Is 2 less than 22? Yep, and so they have to work for both. So since it works for both, that would be my answer. What if it doesn't work for the first one? It's not. Cross it out. What if it works for the first one? You have to go to the second one. Because I'm sure one of these works for the first one, but not the second one. Does that make sense? So when you're given points, plug it in, plug it in. Now, this one, you need to be careful. It says which could not be used to solve for the same x and y. So remember how we manipulate things, like we manipulate equations so that they're the same number, different sign? So here they did it a couple times. So let's figure out the pattern first that's going on. So I'll start right here. And so from 12 to 4, what do I multiply to 4 to get it to be 12? 3. So what is 3 times 4? We get 12. 3 times 2? 6. Good, that's right. And 3 times 22? 66. We know that one works. Then we do it over here, -2. What do we get to get positive 6? -3. So you want to multiply each of these to -3 and make sure that you get the same answer, which you do. -3 times -2 is 6. -3 times 2y is -6y. And -3 times -8 is positive 24. You know that is going to get you the same solution. You're figuring out which one do you multiply and it not be the same.
4.
Not 1, 4. Because if I multiply what -2 times what equals -8? Positive 4, right? So we have multiplied each one by 4. But this one's -8, right? -8 times 4 is not -8. So that one wouldn't be. Remember, some of them may say which one would get you the same solution, while some of them will say which one would not get the same solution. So they're basically manipulating each one. Does that make sense? Okay. Okay, the graph of linear. What does linear mean? Y equals mx plus b, my slope-intercept form. And remember, after school, we're going to be going through this to figure out like when do we use each thing. But for now, I need to figure out first what my slope is. And so when I have these 2 points, that slope formula is given to you. But first, you got to label correctly. So we label and we plug it in. So y2 minus y1 over x2 minus x1. So what's 1 minus 11? And -2 minus 3?
-5.
And what do I end up getting as my slope?
2.
Beautiful. So now I'm going to rewrite my slope, but my slope is going to be 2. Then I need to figure out what my y-intercept is. So remember, you take either of these points. Which one do you want to use? Sure. Let's have them both be positive. And I'm going to plug in 3 for x and 11 in for y to solve for b. Figure out what my y-intercept is. So what is 2 times 3? So you get 11 equals 6 plus b. How do you get b by itself? Subtract 6. So what is your b? 5. So your whole equation, I know this one's long, y equals 2x plus 5, right? That's the equation in slope-intercept form. But now they're not just asking that, they're asking which one of these points would fall on the line. So what do you notice about all 4 points? They all have 2 as the x. So let's plug in 2 to figure out which one. Let's plug in 2 for x. Figure out what my y would be. What is 2 times 2?
4.
And what's 4 plus 5?
9.
So your y coordinate would be 9. So what would be your answer?
4.
So that one we couldn't really plug it in. You would have to figure out the equation. Does that make sense? Okay. Next one, it's asking which point falls in this system, which one is in a solution. So what part of this would be a solution? Would it be 1, 2, 3, or 4? Which number? 3, right? So it's be somewhere in here. And so which one of these points falls in there? 1, right? Because if I go 7, 1, 2, 3, 4, 5, 6, 7, that falls in that region.
Okay. 3 from 1 is like where they.
You mean 3, 0?
Yeah.
3, 0 would be the point of intersection, but that wouldn't be your answer because if it's looking for a solution, it's inequality. See how that's a dotted line? See how this one's a dotted line? And so if it touched the dotted line, it's not a solution. It has, remember, if it was right here, that would be a solution. But it cannot touch the dotted line or it's not a solution. Because remember, it's less than or greater than. Does that make sense? And make sense why they put that? Trying to trick you? Okay. So we're trying to figure out which one of these equations represents this right here. So first of all, what's the first one going to be? A dotted or a solid? Dotted, right? Because there's no line underneath. And what's this one going to be? Solid. So which one doesn't have one dotted, one solid?
3.
Good. Make sure you use that elimination. Then we want to figure out, okay, so the first one has y plus x. Let me erase this. Y plus x is greater than 2. So what letter do I need to get by itself? Y. So how do I get y by itself? Good, and let's make it 1x. And so I end up getting y. Does the sign flip? No, because only when you're dividing by negative. You're not doing it here. Y is greater than negative 1x plus 2. So the dotted line, should I be shading above the dotted line or below the dotted line? Above, right? So which one is this shaded above the dotted line? No, look, see, there's no shaded part right here. What about right here? Is all this shaded above the dotted line? Yeah, so you know that's the answer. You can also do the other one, so you would know that part in the middle is your solution. Yeah.
Said that you couldn't combine.
Yeah, so this one you can't combine, so you rewrite it. So like right here, we're writing it in like slope-intercept form, which is y plus mx plus b. So I put the x first. So like I couldn't make it 1x because I couldn't combine these, so I just rewrote it. Does that make sense? Good point though. Any other questions on this? Okay. So this one's asking for which one has the same solution. So which one is, when I do multiply it, it equals 4. The 1. Yeah. So it ends up being, not 4. Not 4. Which one would be the same if I were to multiply a number? 2. Because what would you multiply to 3 to get it to be 6? 2. So when I multiply, it would still be minus 2y. So it would be 6x minus 2y equals 8. This one has plus 2y. So they're saying it's like the other one. So they're saying which one would they have the same solution as the system below? So what you're doing is you're manipulating them. You're figuring out what can I multiply to each one and get it to be the same answer. So like, for example, if I did, what times 3 equals 6 down here? 2, right? And so if I multiplied everyone by 2, 2 times 4 does not equal 4, right? So that could be it. They're asking which one would be the same. Right here, you can see they divided each of them by 2, right? So from x to 2x, they divided it by 2. But what is 16 divided by 2? 8. So that is incorrect. So that's why that doesn't work. Do you get what I'm saying? They're figuring out what number they have to multiply to every single term in that line to get you that answer. Or you can solve the system and then plug in x and y and figure out which one will just be the same. Okay. All right. This one actually was from your test. So see how both x and y are on one side of the equation? So would I use elimination or substitution? If they're both already on one side. Elimination, remember they have to be the same number, different signs. So I add, let's put the invisible ones right here. So I have 1x minus 3y equals 6, and negative 1x plus 3y equals negative 6. And so I don't even need to do anything because not only do these have the same number of different signs, so do these, right? So let's just add across. What happens with my x's? Cancels. What happens to the y's? What happens with this right here? And you end up getting 0 equals 0. If you get 0 equals 0, does 0 always equal 0? So what solutions do you have? Infinite solutions. One solution is when you're finding for 1 point. So like when you do it a normal way, like if that ended up getting you 2y equals 10, and then you would divide, like a normal situation would get you one solution. But here, see how everything crosses out? They actually are the same exact line. That's why. If I were to put them in slope-intercept form, they would have the same slope and the same y-intercept. They are the same line. So there would be infinite solutions. If they're the same, and you can even write the same slope and same y-intercept. They're the same line. Does that make sense? 10. Now I'm doing the same thing. I already have two that are lined up, right? So let's just add. What happens with my x's? What happens with my y's? Cancel. So I end up getting 0 equals, what's 10 plus negative 8? 2. Does 0 equal 2? No. So how many solutions do I have? No solutions. So 0, and what type of lines are no solutions? Parallel lines. That means they're never going to touch. So solutions means how many times they touch. If they're parallel, they have the same slope, different y-intercept. It just means they're never going to touch. So there's no solution. Does that make sense? Okay. So this one's saying which one, it might look like multiple common coordinate pairs, right? So that means how many times they touch. This says multiple times. So which one touches multiple times, the lines? B, right? And so what type of a solution would this be? They're the same line. So I want you to see like multiple common coordinate pairs, just means how many times they touch. So which one has more than one multiple times they touch? This one. It literally is the same line. It's infinite solution. So that's what infinite solutions look like. What would this be? No solution. What type of lines are they? No solution. Parallel. What about this right here? One solution. So this right here would be your one solution. And right up here, what would this be? 2. How many times they touch though? Just one. So how many solutions? One solution. So that coordinate, whatever coordinate they touch at, is your solution.
Why wouldn't C be parallel?
C wouldn't be parallel because they're actually intersecting. So parallel means they don't intersect. It's right here.
I didn't see that.
Yeah. Oh, you thought the x-axis was the line. Oh, okay. No, it's right there. Okay. 12. A shop sells 1 pound bags of peanuts for $2 and 3 pound bags of peanuts for $5. If 9 bags are purchased for a total cost of $36, how many 3 pound bags are purchased? So this is an example of one that's not going to be like a plug it in situation. So first we need to figure out what are the two things we're looking at. We're looking at 1 pound bags and what else? 3 pound bags. And we see there's money involved, right? So we know that money goes with money, goes with money. So I'm going to use X for 1 pound bags, and I'm going to use Y for 3 pound bags. So you have to label what you're working with. Then how much is it for a 1 pound bag? 2. Good. $2 for a 1 pound bag, and we're using X for 1 pound bags. How much for a 3 pound bag? $5 for a 3 pound bag. And what's the total money for 12 bags? 36. And then, no matter what they cost, total goes to total goes to total. How many total bags did they get? 9. So they want to know how many 3-pound bags. So they want me to solve basically for y. So how do I get these x's? Because I want to be able to eliminate them. How do I get them to be the same number, different sign? Negative what? Negative 2, right? And you got to distribute the love, right? Everyone's got to get it. So you end up getting negative 2x minus 2y equals negative 18. And then we rewrite the first one. Then what do we do between those two functions? Add them, right? So what happens with your x's? They cancel, right? And what's negative 2 plus 5? 3y equals negative 18 plus 36. Positive 18, right? And so remember, if you get a negative right there, would it make sense if I had negative bags of popcorn? No. So make sure does your answer make sense? Then what do? And what do you end up getting? 6. Y equals 6. And we know that y is talking about 3-pound bags. You want to make sure, sometimes they'll ask for the 2-pound bags. You want to make sure you're solving for what they're asking. So what would your answer be?
If it doesn't make sense and it is negative, does that mean we did something wrong?
Yes. Does that make sense, Bridget? Uh-huh. And so to get your x coordinate, remember, all you would have to do is plug it in. So we know these are the 3-pound bags. Say you needed to get the 2-pound, or the, was it 1-pound bag? How would I get the 1-pound bag? Yeah, solve for x. So we can just use this equation right here. So we know our y is 6 equals 9. I'm just plugging it into this right here. So how do I get x by itself? And what does x equal? 3. So 3 would be the 1-pound bags. I'm sure there's 3 in answer choice. Yep. So you gotta be careful. Does that make sense? Yes. So the point of intersection would be 3 from the 6. Okay. All right, so these are actually in slope-intercept form. And so you know, remember, they're not going to say, hey, Miranda, this is a system of equations problem, right? They may say systems, but if you see 2 different situations going on, you don't have to do it systems. So we have company X, and so you see how there's a per. What does per refer to? Refer to slope. So you know that's probably going to be your slope, right? So it's y equals, what's your slope in the first one? Beautiful. Mm-hmm. Company X. And company Y is y equals what? 9x plus what? 30. So remember, y-intercept is your 1 times b. Then we want to know when they'll be the same. So there's a couple different things you could do. You can go in your graphing calculator and go to y equals and type both the equations in and look at that table and see when are both the y's the same. Or you can always make the equations equal to each other and solve. See how they're both equal to y? See how they're both equal to the same letter? So to see when they're the same, you just make them equal to each other. But you can also type it into your graphing calculator and look at the table and see when the y's will be the same. So how do I get x by itself? Let's subtract 30. If we subtract 50, we're going to be dealing with negatives, and you don't want to mess up if there's going to be a negative. So you would get the same answer, but then you'd be dividing by a negative. You don't want to. So we end up getting 7x. What's 50 minus 30? Plus 20 equals 9x. Then what do you want to do?
Subtract.
Not 20.
Oh, I mean,
7x, right? Because we want to move in with the spread 9x. And what is 9x minus 7x? 20 equals 2x. Then what do? You get x equals what? 10. Now, what is x in this problem?
number of baseball.
Per baseball cap, right? And it says the number of baseball caps. So would 10 be your answer? Mm-hmm. Because sometimes they may say, how much money will they spend total? And sometimes they may be looking for the y coordinate. But here, they only wanted the x
Will
coordinate.
this more likely be on the non-calculator or calculator section?
I don't even know. I would say if it's simple math like this, not calculator, but there's a chance it's going to be. I mean, there's only 10 out of 70 questions. All right. You guys got this down? All right, how do we find from a table where this is, and say this is on your calculator, how do I know where two equations cross at? Same what? That's vertex, don't think of vertex. These are linear equations. So we want to find where they cross. And so,
They're the same x and y.
not even the zeros. When they cross, remember, that means they have the same x and y, right? So which table has the same x and y? Let's look at the table. Coordinates. This one has 2, 3. This one also has 2, 3.
Oh.
It's just when you look at the table, it's the same x's or the same x and y. You know that it's a solution.
Oh.
So on your calculator, remember it looks like this. It will look like x right here, and then maybe like y1, and then y2 if you type both equations in. So at 2, they would both be 3 and 3. So that's how it would look on your calculator. So when you see the y's are the same, that's where they cross. Because they have the same coordinates. Alright. So, what is our solution here? 3, 3, 1. What could we do at that point if they give us the equations and plug it in? But this, you're just looking at the x and the y. Notice they give you the x-intercept, the y-intercept, they give you every other point there. Just make sure when they're talking about the solution, that means where they cross. They're saying, is 3, -1 a solution? So what can we do at that point? Plug it in. So I have -1 instead of y equals 2 minus, what's your x coordinate? 3. I get -1 equals, what's 2 minus 3? -1. Is that, so I end up getting, I just plugged in this for x and this for y.
For the first
one, yeah. And so you do get them, they're the same. So what do you do after that? Now you need to try the next one. So it's 3 minus 2, and what's your y? -1 equals 2 times your x, which is 3. So what is 3? What's negative times a negative? So you get 3 plus 2, which is 5. Is 5 equal to, what's 2 times 3? 6. Are they equal?
No.
So I just plug in y coordinate for y right here, and the x coordinate for x. So then I solve. Because it's technically 3 minus, when you're minusing a negative, remember, it will end up turning to a plus. And so remember, it has to work for both. They did it on purpose where it worked for the first one, right? Is that it? Cool. Okay, so does anyone have any questions about anything with systems? What I would do is, if you were not here on Saturday, I videotaped, and all the open-ended basically that were for practice were on systems. So if you guys want me to, for the rest of class, if you want me to play the Saturday thing, and so you guys can see some of it, or you can listen to it on your device. But if you go right here, let's see. And then if you're coming tomorrow, if you want to get a start on exponential so that you take it before and you know what you're doing, you could also, yeah, I can give you the exponential in a second. But here's the, so here's the assessment guide. Here's a study guide, which has different practice problems, things like that. And then if you scroll down here, here's the open-ended. So here's the whole session that I did with the class.